Okay, thank you very much. Very pleased to be here. Some great speakers so far, so I hope I can keep up to standard. I'll talk a little bit about hydrogen in automotive. Obviously, my position at the moment is with Jaguar Land Rover, and we had a bit of an unveil recently with Thierry Bolloré, our new CEO, announcing the Reimagine strategy, and that had an element of hydrogen in it. So the covers are off a little bit. Now we can talk about hydrogen and the fact that we're working on it. But what I'd like to do is just go over a couple of things that have been already mentioned, of course, the bigger picture of where hydrogen fits in the economy and what's driving my thinking behind why it will be interesting for automotive. And then really, asking the question, why again? It's why is it interesting for automotive? What does it give automotive, and why should we not just do everything with batteries? So with that in mind, can I have the next slide, please? Okay, so this is a fairly well understood picture now. All of the other speakers have mentioned the ecosystem behind hydrogen and how the electricity grid and the hydrogen production and storage can work together for a variety of different end uses. I just wanted to bring some numbers to this actually as well. So, we at the moment in the world, we make and use about 65, 70 million tons of hydrogen annually. And that's predominantly from non-renewable sources, so coal and gas. One of the first things we really need to think about is decarbonising that. And to put that in perspective, in automotive terms, 65 million tons of hydrogen is enough to power the 1.4 billion vehicles on the road in the world at the moment. It's enough to power those for 5,000 kilometers each per year if they were run as fuel cell vehicles. So it's a significant amount of hydrogen that is made and used in the world so far. It's not a new concept to make it, transport it, and use it safely. So that's really the first point I want to make. The decarbonising heating piece, that's been well covered so far. I just wanted to also bring a couple of numbers to the costs associated with electrifying heating in homes. So it seems like a good idea. Take out your gas boilers, put in heat pumps, etc. So about 12% of the UK housing stock is social housing. Various county councils have looked at the costs associated with moving their housing stock to future home standard, which is a path to net zero. It's not net zero. And the cost of that is about £100 billion. Then if we move into the private sector, homes that are built now to current building regs, if to move those to future home standard, which is coming in 5 years, is about a £20,000 ask. Now, a lot of the older housing stock, so we still have 70-odd% of the older housing stock in the UK, to electrify the heating and the cooking, etc., in those houses, but heating particularly, doesn't make sense until you've insulated it properly and you've made it more energy efficient. There's a project in Nottingham called Energy Sprong, which looked at the costs of doing this on pre-war housing stock, pre-1914 housing stock. They had a target of £60,000 per house, but they didn't manage to achieve it. So the costs to the end user of electrification of home heating and home cooking is really has to be considered in the mix here. But as all the other speakers have said, it will be a blend. Future homes, yes, certainly electrification is a viable way forward, but retrofitting, we really have to consider where we're going to get the money from to do that. I won't go into the energy system smoothing again, because that's been well covered, or the decarbonisation of steel making processes, things like that. But then my speciality is the transport applications. So transport applications where you just need a lot of energy on board really do benefit from the application of hydrogen. And this means heavy vehicles that tow, heavy duty vehicles that need large load capacity, vehicles that need to refill quickly because they are on quick turnaround duty cycles, and also vehicles that operate in low temperature conditions where you need a lot of energy for maintaining cabin comfort. So there are a lot of reasons why you might use hydrogen in the heavier transport application. So if I could have the next slide, please. So the one that we're really about, JLR, is customer experience. You know, what does our customer experience, and is that experience good? The upside to hydrogen with in automotive, in passenger cars, is the convenience of a quick fill. And then once you get into longer journeys, so just to explain the chart on the right there, the light green bits are traveling time and the dark green bits are stopping time. And if you take a notional longer journey, 800 kilometers, you come to the conclusion that a battery car with a decent range in good conditions, i.e. 25 degrees Celsius, it takes about an hour and a half longer to do 800 kilometers than it does to do it in a fuel cell or a combustion engine car. And that's true whether you are driving a passenger car or a heavy duty vehicle. You know, it's about the average speed you can actually maintain on those long journeys. Okay, if I could have the next slide, please. But there aren't any hydrogen filling stations around anywhere. That's the criticism. No hydrogen stations around. Well, yes and no. I mean, there are places in the world that are really going, you know, headfirst into hydrogen economy, and you know, Japan really has been the leading light there. And the commitment to hydrogen stations has ramped up in recent years, and my view is that it will continue to exceed the stated objectives already in the places that are interested in hydrogen economies. In Europe, I think Germany is probably the highlight as the leader there, with over 90 filling stations at the moment. And the question really comes down to how many filling stations is enough? Where do we need to get to? I have, within 2 miles of my home in Nottingham, I have 19 petrol stations. That's clearly too many. So the rule of thumb that I work to, and a lot of others work to, is about 1 in 20 fueling stations should be hydrogen capable to provide a good coverage nationally. And in the UK, there are about 8,000 filling stations, petrol, diesel. So that means if we could get to about 400, we would have a very substantial network. Okay, if I could have the next slide, please. So coming back to why are automotive interested in hydrogen? Why not just do it all with batteries? The mass of the power pack, and I'll explain that in a second, is significantly lighter when you need a lot of onboard energy. It's significantly lighter for fuel cells and hydrogen when you need a lot of onboard energy. What I did in this slide, a little bit busy, apologies for that, is I made a calculation of the onboard energy available from either a battery power pack, so that is just the battery on a BEV, or a fuel cell power pack, and that means the fuel cell system, so the fuel cell engine, the DC converter, a hybrid battery to give the same power as the BEV battery, and the hydrogen tanks. And you can see, of course, what happens is the relationship between energy and mass with batteries is linear, and that's shown in blue for 2021 and projected out to 2030. so if you increase the amount of energy you need for, or you want on your vehicle for propulsion, then you need to increase the mass of the batteries. With fuel cells, of course, you start with the fuel cell engine, the mass of that initially, with zero hydrogen on board or zero tanks. And of course, you have no energy on board for propulsion, but you have some mass associated with the engine. And then you increase the energy available for propulsion by adding fuel tanks, so hydrogen tanks, really. And you can see, obviously, there's a crossover in 2021 at 55 kilowatt hours thereabouts. The fuel cell power pack becomes a lighter weight option than the battery power pack, so the battery unit. Projecting out to 2030, that goes in favor of battery somewhat, in that the crossover point becomes around 85 kilowatt hours. So there's a lot of debate in the industry at the moment about exactly how much energy we do need on board. And you can see those grey lines lurking in the back there. What I've done there is I've scaled the available energy on board for a battery vehicle at -7 degrees. So at -7 degrees, if you go to Argonne National Laboratory website, you can get some really good data on the range loss at low temperature for a number of battery vehicles, and it comes down to about 40% compared to 25 degrees C and -7 degrees C. So you can see there that even in 2030, fuel cell and hydrogen has a significant mass advantage on board. Okay, if I could have the next slide, please. The other key challenge for automotive, of course, is the battery material supply constraint. The challenge of decarbonizing transport is absolutely massive. The takeaway from this slide should be that the ramp up needed in battery supply just to deliver on transport decarbonization is absolutely huge. There will be a lot of stress on supply chain there. Decarbonizing transport with batteries alone, I think, is a huge risk. We will need not just fuel cells and hydrogen, but we will need synthetic fuels, whose feedstock, by the way, is hydrogen, to deliver on the decarbonization challenge. Okay, if we can have the next slide, please. So the controversial question I will leave you with is, are we in or out? Really, I've spent a lot of time in China and Japan over the last 7 or 8 years, and I see a very bullish approach there. And the map, this is a very good slide from FTI Consulting. Thank you for the use of that. And the question really is, do we want to be a part of the hydrogen rollout and the hydrogen economies that are emerging around the world, or don't we? It's a very simple question. So, and I hope the hydrogen plan strategy will bring some answers to that. Thank you very much.